Hey everybody, this lesson is going to be short and sweet, so let's dive in. It's just going to be informational. There are no math problems for this particular lesson, and it is all about simple machines. Simple machines were developed by ancient peoples to overcome friction and resistance and basically to do more work with the same potential and kinetic energy. So the goal of all machines, do more work with less effort. Yay! There are 6 types of simple machines. Know all of these. Memorize all of these. Know these really well. I have no idea why, but you should really know all 6 of these thingies. Now let's walk through each one of them one at a time. First off, we have a wheel and an axle. A wheel and an axle consists of a large wheel that's fixed upon a smaller wheel, otherwise called an axle. Now your car has an axle that over here, is connected to a drivetrain. But anyway, so this axle is connected here, and that turns, and this turns, and ultimately then it turns the wheel, and your car moves, and that's happy days. This other wheel, this guy here, that means that the axle turns and in turn turns the wheel as well, so then both turn. So for this to work, either the wheel just moves, the axle just moves the wheel, or the wheel can move the axle and that can move a bucket up a well and you can drink water instead of dying. So here's a wheel and we turn it that way, and that turns this axle, and then that in turn turns the rope, and then it pulls up water, and you don't have to exert so much energy because, yeah, wheels are awesome. So wheels and axles. Next, we have a pulley. A pulley is nothing more than a grooved wheel. So there's a wheel, and it has a groove in it. Yeah, and we stick a rope in there, and we attach a weight to it, and then we pull. Now, we only count the efficiency or the mechanical advantage, which you'll learn about in just a second, when things go with the motion. So our ball, or whatever this is going up, and we only have one rope also going up because this rope, by the way, is going down, so therefore the mechanical advantage of this pulley is 1. And you have no idea what that means, but don't worry about it. We'll talk about that in the next unit or the next lesson, and I figured you should be exposed to it now. So there you go. See, used to increase mechanical advantage, and you thought I was crazy. A movable pulley is where we have, this is a single pulley. There's this guy. He's kind of lonely, so we add a friend, and we move a rope there and move a rope there, and now we have 2 pulleys, and a bunch of more ropes, and we do more work because, again, we increase mechanical advantage, which is good because the entire goal of all simple machines is to increase mechanical advantage, therefore allowing us to exert the least amount of force possible and, again, achieve our ultimate state of laziness. Then we have an inclined plane. This picture is so incredibly detailed. Inclined plane, super fancy machine, right? There's a piece of wood on an inclined plane, and that actually reduces the force of gravity, which is cool because, again, that increases mechanical advantage, which is the point of all simple machines. In this picture, you actually have 3 simple machines. You have a wheel and axle, you have a lever, and you have an inclined plane. Whoa, that's craziness. And then we have a wedge, a thing like an axe. And a wedge is just an inclined plane. See, inclined plane like that, and like that, and like that, but then laid on its side. So then we can I guess if it's set this way, we can then smash it into a block this way and split things apart. Otherwise, see, my drawing is almost as good as this picture here. You know it is. So a wedge is just something you drive in between something, and it spreads them apart. So if you have a friend like that, perhaps you should not be friends with them anymore. And then we have a screw. A screw is a thing that allows for rotational force to become linear. What that means is, you can see in this picture, we have a screw, and we have a bunch of rotations or circles attached to a line, attached to a gear, and what that does is it allows, as the wheels turn, if you will, it pulls up a little bit of water in each increment, and it dumps it here. And this takes way less effort to do than if I were to just take a big giant bucket and lift it straight upwards. Okay, so this again increases mechanical advantage, and that's a screw. And then we have a lever. A lever is a rigid bar that rotates around a fixed bar called a fulcrum. You've seen these before. They're called teeter-totters. Okay, they're fulcrum. And then here's Susie, and here's Johnny. Johnny needs to go on a diet. Johnny will have a lot of force here and will lift Susie, who's really tiny for her age, so that's the load, and that's the effort, and that's the fulcrum. And there are three classes of levers, which we'll talk about coming up, I think, somewhere right around the next slide. So again, fulcrum. Effort is the force that you input, so that is input force. And then you have load, which is also called the output force. And what we really want is that output force is way bigger than the input force. Yay. Okay, so there are three classes of levers. Yes, I would know these. That's not a star. There's a star, and there's a star, and those are crappy stars. Let me try. Star. There we go. Okay, so know these guys. These guys are important. Again, I don't know why. The first class of lever is the classic seesaw example where you have a fulcrum and you have output force on one side and input force on the other. Remember, input force is the same thing as effort. Output force is the same thing as load. So that would be the same type of thingy as like a pair of pliers or a teeter-totter or something of that light. So you input a little tiny force and you get out a big output force. That's first class lever. Second class lever, your fulcrum, dang it, it's been moved all the way to the end. Your input force still goes up here on this end, and the output force is now somewhere in the middle. So your load's in the middle, your effort's in the back, and hey, we have a wheelbarrow, and that's a second class lever. And then finally, we have a third class lever, and the third class lever has a similar setup, but slightly different than the second one. So third class lever, fulcrum is still at the end, just like second class. The big difference? Input and output force have now shifted. So we have effort here and we have load here, whereas in second class we had effort on the end and load in the middle. So input force, if we look at our elbow, there's our fulcrum, elbow. We have an input force. That would be like our bicep connecting to the tendons in our forearm. That's where our input force comes from. And then voila, our load or a dumbbell gets lifted up. So that is the effort force. Why use a machine? Well, there are four reasons. You have transferring a force from one place to another. You have changing the direction of a force. You have increasing the magnitude of a force. And you have increasing the distance or the speed of a force. And those are your four reasons why you would want to use a machine. And I'm pretty sure that's a homework problem. You probably want to know that for some exam coming up. And ultimately why you want to use a machine is that you want to do more work with less energy, less effort. So we can all achieve our Zen-like state of laziness. Oops. How do simple machines work? They give you a mechanical advantage. So therefore, your input force is small and your output force is big. And we get a mechanical advantage. And we'll talk more about that in the next lesson. Peace.